So today we are going to talk about simplifying, multiplying, and dividing rational expressions. So for some of you, you saw this in Algebra 2 in the fall. If you had Algebra 2 in the spring, this was something that we did not get to. Okay, so first off, a rational expression is one where two polynomials, like the ones here, this is a polynomial, and this is a polynomial. They're in the form of a fraction. So dividing two polynomials, one in the numerator, like this one in the denominator, like this one. So the key to simplifying a rational expression is to be able to factor. Okay, so if we have a rational expression that looks like these, we can simplify it by writing each part as factors. Then we cancel out any common factors. So the same thing that may be on the top and the bottom. Okay, so we've got to factor each piece of this. So I'm going to start with the top. Okay, first off, remember we always look for a greatest common factor. There is no greatest common factor here. So I'm going to do my bottoms up method because I have a 3 in the front. So I'm going to start by multiplying 3 times 6, which will give me x squared minus 7x minus 18. Okay, now I'm looking for my factors of 18 that subtract to give me a negative 7. So my factors of 18 are 1 and 18, 2 and 9, and 3 and 6. So to get a negative 7, I will use 2 and 9, but my 9 will be negative. So I'm going to use the 2 and the 9. So x plus 2, x minus 9 would give me that negative 7 when I add them together. Then I have to come back. The number that I originally multiplied by has to be divided back out. So can you divide 2 divided by 3? You cannot. So this 3 will come up in front of the x and become a 3x plus 2. 9 divided by 3 is 3, so I get x minus 3. So that is what the top factors to. 3x plus 2 and x minus 3. Okay. Now the bottom is x squared plus 2x minus 15. Since in this case, essentially this is just a 1, all I'm looking for are my factors of 15 that subtract to give me 2. So I'm just going to list these out. 1 and 15, and 3 and 5. Okay, I need a positive 5. Okay, I know that because I'm subtracting, I'm going to use the 3 and the 5. Okay, but because I need a positive 2, that sign is going to go with the larger number. So I'm going to have a positive 5 and a negative 3. I'm going to come back up to the problem and write that in. X minus 3 and x plus 5. So once you have factored everything, you will then cancel anything that's the same on the top and the bottom. So in this case, x minus 3 will cancel, and 3x plus 2 over x plus 5 will be your simplified answer because it did not cancel out. Okay, so let's take a look at a few other ones. All right, so if we look at example A, if I want to factor the top, so I have x squared plus 5x. Okay, this is just a GCF, so you can factor out an x from both of these. You cannot factor out a number because all you have is a 1 and a 5. So if I factor out an x squared divided by x is x, and then 5x divided by x is just 5. Okay, so that is the top. And then the bottom is x squared. I'm going to write that out as x times x. The reason I'm going to do that is because now when I'm looking to see what I can cancel, I can cancel one of the x's on the bottom with that 1x on the top. And so now, just writing my answer, I have x plus 5 over x. Okay, so example B. All right, I'm going to start by factoring my top. X squared minus 5x minus 6. All right, I'm looking for factors of 6 that subtract to give me a negative 5. Okay, so that is going to be 6 and 1. And in order to get a negative 5, the bigger number is going to take that negative. So when I multiply those, I get negative 6. When I add those, I get negative 5. Okay, so that's going to be the top. And then the bottom is x squared minus 1. Okay, hopefully you recognize that as a difference of squares. X squared is a perfect square. 1 is also a perfect square. So this will factor into x plus 1 and x minus 1. All right, I'm going to come back up to the top and rewrite those together. X minus 6, x plus 1 was the top, over x plus 1, x minus 1. Cancel anything that's the same on top and bottom. So that's the x plus 1s. Right? And that leaves me with a final answer of, so I'm going to write my answer here, x minus 6 over x minus 1. That's my simplified answer. All right, example C is actually multiplication, but the rule is just the same. You factor everything, both bottoms, both numerators, and both denominators. And then you cancel anything like we've been doing, okay? So if you look over here on this, on the left side, x minus 3 and x plus 2, you can't do anything with that, okay? So those are going to stay the same. The top here, so I'm just going to rewrite this and bringing it down. So x minus 3 over x plus 2. Okay, so the top here now, so I'm factoring the top, x squared plus 5x plus 6, factors of 6 that add to give me 5. Okay, that will be 2 and 3. Okay, and then now the bottom, this is another difference of squares. I have two terms, they're both perfect squares, and it's subtraction. So this will be x plus 3 and x minus 3. All right, so when you're looking at this to cancel stuff, you look at it as a whole. Okay, so I'm going to start with this x minus 3 over here on top. Do I have an x minus 3 somewhere in the denominator? Okay, I do over here. So I'm going to cancel those out. What about x plus 2? So I have one here and here. And then the x plus 3s, I also have that as well. Okay, so everything can canceled out in this problem. So if everything canceled out, I can't just say the answer is nothing. Everything canceling will make your answer a 1. Everything canceled, therefore I have 1 as my answer. Okay, so let's take a look at one more multiplying example. All right, so I need to factor everything. Okay, so I'm going to start with the top. 4x minus 2x squared. Okay, I'm going to actually work this out to the side over here so everybody can see it. Okay, I know I can divide those both by 2. But they also both have an x in common. Okay, so this has the greatest common factor of 2x. So 4x divided by 2x is just 2. 2x squared divided by 2x is just x. So that top simplifies to 2x 2 minus x. All right. And now the bottom, x squared minus 5x plus 6, that will factor into 2 and 3 in order to get that negative 5. They are both negative. Okay, and then the top over here, x squared minus 4x plus 3. Okay, well, factors of 3 are just 3 and 1. But I need a negative 4, so they're both going to be negative. And then I have 2x. All right, so there's one thing that we need to do. If you notice this piece right here, it's kind of backwards than the rest of it. Okay, so what you're going to do in this case is, in order to switch it around, you can switch it around, but you're going to have to make whatever's in front of it negative. Okay, so that's what I'm going to do in this step, is make this a negative 2x, and actually now I can switch it around and it will become an x minus 2. Okay, I can only do that by pulling out and factoring out a negative 1. So I'm just going to rewrite the rest of the problem.
Teachers, pardon the interruption. Jackson Crowley, if you're in the building, I need you to report to the main office. Thank you.
All right, and then I'm going to start canceling. So this 2x can cancel with the 2x here on the bottom. This x minus 2 can cancel with that one. And this x minus 3 can cancel with that one. So when I cancel all the stuff, I'm just going to bring over what's left. I have a negative, okay? And then I have x minus 1, okay? So you can leave it like that, or you can distribute it and make it negative x plus 1. And that would be my simplified version for that. Okay, so in the next video, we're going to talk about dividing rationals.